This is questions 1, 3, 5, 8, 9, 12 and 13 in exercise 5.3 in Project Maths 2. We've got to express each of the questions in the form A, where A is an element of Z. In other words, each of these questions is going to simplify down to just a whole number. So let's look at the first one here. We've got root 2, root 2. When they're written like this, it means root 2 multiplied by the root of 2. When you multiply the root of 2 by the root of 2, you're just going to get 2. The square roots are going to cancel each other out. And by the same reasoning, when we look at question 3, we've got the root of 5 squared. Well, the square and the root 2 will just cancel each other out, and we're just going to get 5 for this one. Now this happens when it's the same number under the square roots like we had in 1, or the way we would have if we wrote this out as a multiplication for 3. For question 5, it's a little bit different. What we've got is root 2 times root 8. But when you've got it like that, what we can do is we can actually put the square root over the entire product. So what it can become is the square root of 2 times 8, which is going to be equal to the root of 16. And 16 has a square root, and that's 4. So we just get 4 for that one. In question 8, you can see we've got 4 root 5 root 5. So that's 4 times the root of 5 times the root of 5. So that's going to be 4 times the root of 5 times 5, which is 4 times the root of 25. So that's 4 times 5. So we just get 20, like that. Alternatively with this one, the way we could have approached is the way we approach questions 1 and 3, where root 5 just gives us 5, so we get 4 times 5, and we get straight to the point much quicker, and we get 20. So that is one or the other. We didn't need to do both of those methods. It's to the left of the line or right of the line. And for question 9, we've got 2 root 5, 2 root 5. So that's 2 times root 5 times 2 times root 5. So we can rearrange that slightly and write that as 2 times 2 multiplied by root 5 times root 5. Now 2 times 2 is 4, and root 5 times root 5 is 5, so we get 4 times 5, so we get 20. We've got a similar sort of thing going on here with question 12, where we've got 3 root 2 squared. That's just 3 root 2 times 3 root 2. But alternatively to that, what we can do is, when we get a situation like this square applies to each number inside of each of the factors inside of this product separately. So that's actually going to be 3 squared times root 2 squared. Now 3 squared is 9, and root 2 squared is 2. So we get 2 times 9, so we just get 18 for that one. And then for question 13, which looks more complicated than it actually is. We could expand the brackets out the way we would normally when we've got two brackets of this. So we've got root 2 times root 2, then root 2 times minus 1, then 1 by root 2, and 1 by minus 1. But what we actually have here is the factors of a difference of 2 squares, so we can jump straight to that. So let's try that approach first, and then we'll do it where we expand the brackets, and we'll see that they are going to be equal to each other. So as that's a difference of 2 squares, what that would have looked like before you factorize would have been root 2 all squared minus 1 squared. So that's 2 minus 1, so you just get 1. But let's do this where we actually expand the brackets out. So we'll start by multiplying everything in the right bracket by everything in the left. So root 2 times root 2. Root 2 times root 2 is just 2. Root 2 times minus 1 is minus root 2. 1 by root 2 is plus root 2. And 1 by minus 1 is minus 1. Minus root 2 plus root 2 is just 0, so we end up with 2 minus 1, in which case we just get 1 again. So see that it works out exactly the same way, whichever way you go with it. So you can expand the brackets if you prefer, but if you do spot that it's a difference of 2 squares, it goes a little bit smoother. And that is that.